Hi everyone, here are your section 8.4 notes. Today we're going to be getting into adding and subtracting radical expressions. So please always proceed with caution. You can only combine radical expressions that have the same index. Remember, the index is a little number in the radical check mark spot, and they must have the same radicand. So you can only add something like a square root of 2 plus a square root of 2. You can't add a square root of 2 plus a square root of 3. Or you can't add a cube root of 2 with a square root of 2. So they need to have the same index and they have to have the same radicand in order to be combined. So here we have an expression. Right away, I do notice that they do have the same index. Those are both square roots, but they don't have the same radicands. One of my radicand is 24 and the other one is 54. So we need to try to see if I can convert them so that they do have the same radicand, because they probably do. So let's go ahead and simplify the square root of 24. My largest perfect square that goes into 24 is 4. Square root of 4 is 2, so that simplifies to 2 square roots of 6. But I have that 3 in front, so I need to multiply it to get 6 square roots of 6. Now let's do the same thing with 54. Now here's the cheat. I know one of those factors needs to be 6. So if I divide 54 by 6, that gets me 9. So it makes it a little bit easier the second time through. So that becomes 3 square roots of 6. So now I do have a square root of 6 and a square root of 6. So if I had 6 square roots of 6 and I added 3 more square roots of 6, then I have a total of 9 square roots of 6. Right? So if I physically drew out 6 square roots of 6, and then added 3 more, I would have 9 of them in total. Okay. All right, let's look at this one. We have 2 times the square root of 20x minus the square root of 45x, and it's just telling us that x has to be greater than or equal to 0. That's just covering our butts because we know that we can't have negatives underneath a radical sign. So let's simplify 4 and 5. So that would go to 2 square root of 5. Multiply that 2 with that 2 to get 4 square root of 5x. And then 45 is going to be 9 and 5, which would go to 3 square roots of 5x. So I have 4 square roots of 5x minusing 3 square roots of 5x, which would leave me with 1 square root of 5x. And again, x needs to be greater than or equal to 0. Let's add or subtract and simplify the expression. So here we have a square root of 3 and a square root of 5, so we do have the same index, but unfortunately I can't simplify a square root of 3 any further, and I can't square root or simplify a square root of 5 any further, so it cannot be cannot be combined, I guess we could say. Cannot be combined. Can't happen. It can't go any further than 2 square roots of 3 minus 4 square roots of 5. Next one. Okay, so here we have 2 cube roots of 16 minus 5 cube roots of 54. So now we're in cube root world, right? So let's quickly remember our cube roots. Our first perfect cube root is 2 to the third, so 8. 3 to the third is 27. I don't think I have to go any higher than that because my numbers are 16 and 54, or 54. So 16 would be 8 times 2. The cube root of 8 is 2, and I'm left with a cube root of 2. Multiply these 2's together. So we get 4 cube roots of 2 in that first. Now for my second one, looks like 54, does that divide by 27? I think it's 2, isn't it? Which, yeah, I should have known that because I know one of my factors has to be 2. So the cube root of 27 is 3, and I'm left with a cube root of 2. Multiply my 3 and my 5. So that becomes minus 15 cube roots of 2. So 4 minus 15 gets me negative 9. Nope, negative 11 cube roots of 2. All right, now we're getting even crazier. Now look at all these variables I got involved. Okay, so let's do some simplifying. Can I simplify this? My index is a 3, my exponent here is 2, my exponent here is 1, so that doesn't simplify any further. Here I have an index of 3. I do have a 5 that's higher, so I can simplify my x to the 5th, and I can simplify my y to the 4th. And I can do a cube root of 8, right? Because isn't the cube root of 8 2? And then how many times does 3 go into 5? Once with 1. How many left over? X squared. How many times does 3 go into y to the 4th? Once with 1 left over, which is good because now my radicands are the same. So now I have 2 cube roots of x squared y plus 2xy cube roots of x squared y. Well, I can't add 2 and 2xy. So what we can do is we can factor out all the greatest common factors. So everything that's in common. So what's in common? I've got a 2 and I got a cube root of x squared y. So if I take that out of the first, I'm left with 1, right? If I take it out of this chunk, that's everything. So I'm left with 1. Plus, if I take out the 2 here and take out there, I'm just left with xy. So that's how we're going to simplify it further. Here we have 5 square roots of 4x to the third plus 3 cube roots of 64x to the fourth. Let's go ahead and simplify everything. I don't think we're going to be able to simplify any further. The square root of 4 is 2. That becomes an x, square root of x for x cubed, multiplied by 5, so 10x square root of x. 64, I think that's a perfect cube, isn't it? 64 to the 1/3 power is 4. Yep, that is a perfect cube. So that becomes 3 times 4. It looks like we're going to get an x out and then a cube root of x. So plus 12x cube roots of x. All right, so what do we have in common that I can factor out? Well, I can factor out a 2 and an x. So now I'm left with 5 square roots of x plus 6 cube roots of x. We'll leave it there. Ooh, fractions. Fractions are our friends, everyone. Okay, so remember we can simplify by doing the numerators and the denominators separately. 75 would be 25 times 3, so 5 square roots of 3, the square root of 16 is 4, times that 2 in front, so that becomes 10 square roots of 3 over 4, which simplifies to 5 square roots of 3 over 2. Now let's go over here. Square root of 8 would be 4 times 2, so 2 square roots of 2. 32 would be 16 and 2, so 4 square roots of 2. My square roots of 2 are going to cancel. Bring down that 4. My 4s are going to cancel, so I'm left with plus 2. That's all that goes to. So now how can I combine that together? So 5 square roots of 3 over 2 plus 2 over 1. Common denominator would be 2, so 5 square roots of 3 over 2 plus 4 over 2 comes together to make 5 square roots of 3 plus 4 all over 2. Whew, we're getting even crazier now, guys. I know you're all getting so excited. All right, cube roots. Let's do the same thing. I can't simplify a cube root of 5. A cube root of x to the 6th, that's just going to be 2, right? Because how many times does 3 go into 6? 2. So now I have a cube root of 5 all over 2. Bring down that times 10 in front. So that goes to 5 cube roots of 5. And then on the other side, we have a cube root of 4. Can't take that over x to the 3rd minus 3. So now we have, bringing it all together, we got 5 cube roots of 5 minus 3 cube roots of 4 all over x to the 3rd. You can just leave it there if you want. If you want to come up with a common denominator, your common denominator would be x to the 3rd, which would make you need an x to the 3rd there. So technically I could take it to 5x to the 3rd, cube root 5 minus 3 cube root 4 all over x to the 3rd if I wanted to write it as one fraction. And that ends your notes. Bye, everyone.